So the tangent of 0 is actually the tangent of pi over 4 is 1. The tangent of pi over 2 is the tangent of 3 pi over 4 is what kind of 1?
Negative 1.
The tangent of pi is
0.
Tangent of 5 pi over 4?
1.
Tangent of 3 pi over 2?
Undefined.
Tangent of 7 pi over 4?
Negative 1.
2 pi?
0.
Alright, on to the negatives. Negative pi over 4?
Negative 1.
Negative pi over 2?
Undefined.
Negative 3 pi over 4?
1.
Negative pi?
0.
Negative 5 pi over 4?
Negative 1.
Negative 3 pi over 2?
Undefined.
Negative 7 pi over 4?
1.
And negative 2 pi?
0.
Alright, what did we say that undefined meant, Josh?
Oh, asymptotes.
Thank you. Undefined equals asymptotes. That's the first we got, right?
Yeah.
Alright, so now we're going to talk about how to graph the tangent function. Okay, when we're graphing the tangent function, what we have to be mindful of is the parts that it's divided into. Okay, notice that the tangent function has fourths. Have we had to deal with fourths thus far? No, we've had to deal with halves and thirds and sixes, but now we're going to actually deal with fourths. However, our graph is still staying in 6 pieces. Well, what is the least common multiple of 2, 3, 4, and 6? What is the least common multiple?
1, 2.
Multiple means that all of them are divisible into that number.
2, 3, 4, 6.
2, 3, I heard it.
12.
Thank you, Vicky. 12. So my least common multiple is 12. And you said it after her, Jose, so thank you too. But okay, so we have to divide our 6 pieces into 12 pieces. How can I turn 6 into 12? Divide it, right? Divide into how many parts? 2. So I can take each 6 piece and divide it into 2s. So if I cut each piece in half, what that does is it now turns my graph into 12s. So each line is 1 12, 2 12, 3 12, 4 12, 5 12, 6 12, 7 12, and so on and so forth. And so now I have the ability to graph any of those fractions in one graph. Got it? And if this is not enough halves, I will divide wherever I mean in half. So just to go ahead and get it over with, I'm going to divide it all in half. Alright, so now my graph, instead of my units being pi over 6, my units are now what? Pi over 12. Thank you, Casey. Alright, so let's draw in our asymptotes first. Again, an asymptote is a what?
Breaking point.
A stopping point, a boundary line. Okay, so where are my asymptotes at?
Negative 3 pi over 2.
Negative 3 pi over 2.
Negative pi over 2.
Negative pi over 2.
Pi over 2.
Pi over 2.
3 pi over 2.
And 3 pi over 2. Okay? It's easier for me to just draw the line and then go back and erase. So there's my invisible boundary lines that we need to make visible in order for us to graph. So boundary lines are done. Now it's all that's left is to plot the point. Okay, can I cross the boundary line? No. So that means that wherever my points or my function ends up doing is just going to steadily approach it, but it will never pass or touch it. Okay? Alright, so let's plot our points. Where would pi over 4 be?
In between pi over 6 and pi over 3.
Good, thank you for reading, Josh. Pi over 4 is in between pi over 6 and pi over 3. The reason why that is because pi over 4, if I have 1/4 and I need to change it into 12s, what would that have to be? 3. So that means it will be my third 12th mark, right? So 1, 2, 3, which lies in between pi over 6 and pi over 3. And the value is 1?
Yes.
Okay? What?
Yeah.
Alright, what? Again, it said pi over 4, right?
Yeah.
But what are we counting by? 12. So how can I make 1 4 into 12? It's going to make it into 3 out of 12. So now I can count 3 tick marks, and that's where pi over 4 would exist. Okay, you have to take what you have and make it match your scale. Alright, where are we now? Pi over 2? We already did. Oh, we forgot 0. Okay, what's next? 3 pi over 4. So where would 3 pi over 4 lie?
3 pi over 4, that's between 3 pi over 2 and 6.
9.
It will be what?
9 over
It will be 9 over 12. 3 over 4 equals 9 over 12. So how many tick marks do I have to go? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 pi over 4 is in between 2 pi over 3 and 5 pi over 6. So here I'm going to put -1. At pi I'm going to put 0. Okay, what's my next one? 5 pi over 4. What's 5 pi over 4? It'll be 15. So to go from 5 over 4 to 12, I will multiply the denominator by 3. So what I do to the denominator, I have to do to the numerator. So how many tick marks in am I going? 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I'm going to put a 1. All right. So now we're at 7 pi over 4. What's 7 pi over 4? 21 out of 12, right? So this is 15, 16, 17, 18, 19, 20, 21. At 21, I'm going to be at -1. And what's 2 pi? 0. Okay, at your table, I want you guys to practice graphing the negatives. So you guys are going to do the negatives.
I already did it.
Good job. Don't connect the dots yet unless you understand how to connect them. Here we go. So, your graph should look like so. Do your graphs look like this?
Yes.
Okay, clearly the calculator isn't going to show you the asymptotes, but you know they exist, right? That's why the graph is not connected. All right. So, let's talk about this, and let me connect my dots. Is it right here? Is that my -1? All right, so I'm going to connect the dots. Now, I'm a horrible tangent drawer. Hey, I'm doing better right now. Okay, so there's my tangent on that side. This is actually 2 cycles of a tangent. Well, 2.5, because that's half of a cycle. So this is 1 whole cycle. From one asymptote to another asymptote is a whole cycle. Okay? The space that a cycle occurs in is called the what? What's the P word?
Period.
Period. So this is called a period. How long is my period?
It's a pi. No.
If I have a half a pi here and a half a pi here,
That's a whole pi.
it's a whole pi. So my whole period is pi. Okay? So every pi period, I repeat this cycle. Okay? Now, next thing we notice. First off, it goes through the origin, right?
Yes.
All right, well, let's determine. Is this even, odd, or neither?
Neither.
Why is it odd, Vicky? I can rotate it around the origin. If I took this function, it doesn't highlight very well. and it doesn't show the rotation. But if I took this function and I rotated it, is it going to look different? No, it's going to be the exact same. I'm steadily still increasing. I'm still increasing, Mark. Yes, so it's odd. Alright?
Did you get scared?
Alright, so let's fill in what we know. So what did we say the period was? Pi. So unlike sine and cosine, whose periods were what? 2 pi. Tangent is only 1 pi. Okay? Vertical asymptotes are where? Okay, so based on what I see, my vertical asymptotes are at pi over 2. However, if I talk about this in general senses, what this tells me is that if I look at it, I have one at pi over 2 and pi over 2, and the pattern continues pi over 2, 3 pi over 2. Notice that it's at, that my vertical asymptotes are at odd multiples. My pen is really large. At odd multiples, guys, of pi over 2. No, this is my asymptotes. My vertical asymptotes are at odd multiples of pi over 2. So if I did pi over 2 times 1, pi over 2 times 3, pi over 2 times 5, pi over 2 times 7, pi over 2 times 9. Those are called what kind of numbers? Odd. Okay? Those are my odd numbers. That's why it says odd multiples of pi over 2. Got it? Alright, now let's talk about our domain. Because we have, guys, all these side conversations. Okay? Because we have these asymptotes, that means my domain is not continuous, is it? No, my domain is restricted. Okay? My domain is restricted because of these asymptotes. Now, so the best way for us to write this is that simply to say what our domain does not equal. Okay? So our domain doesn't equal what? The what?
Undefined.
Why?
Because it never touches you.
It never touches them. So our x doesn't equal the odd multiples of. I just dragged my foot. I moved my foot and it made a squeaky sound. Alright, so x doesn't equal odd multiples of pi over 2. We could write that in set or interval notation, but I think the best way for you guys to remember is just know that if these are my asymptotes, that means that when it comes to my domain, they don't exist. Alright, what about my range? It is all real numbers. My range goes from negative infinity to positive infinity. There's no break in my range and no restrictions to my range. What about my x-intercepts of this function?
0, 0. Negative 2 pi. 0. Negative pi. 0. Positive pi.
Okay, so in the window that we have on our notes, it would be negative 2 pi, negative pi, 0, 0, positive pi, now what does that tell me though? If I expanded my window, or I wanted to make a prediction on if I expanded my window, where would my other x's be? My other intercepts would be?
The even multiples of pi.
Not just even. Is 1 even?
Oh.
No, it would just be at all multiples of pi. Because it goes from 0 pi to 1 pi, 2 pi. What will be next? 3 pi. What will be next? Then So on and so forth. That's what it's called, a pattern. That's why we started off this unit talking about patterns. Because in trigonometry, if you can recognize patterns, you make your work easier for yourself. Okay? So same thing this way. It would, instead of going 0 pi, negative 1 pi, negative 2 pi, it would be so on and so forth. That's where all of my x-intercepts exist. So on your test, if I asked you, what are the x-intercepts of a parent function of tan greater than 2, what should you say?
3 pi, 4 pi.
You should be able to say 3 pi, 4 pi, 5 pi. Or if it said, give me examples of x-intercepts greater than 2 pi, you should understand that pattern. Does that make sense? Yes, Casey?
End of the year, can we have a pie party?
Sure. We can celebrate Pi Day.
But we all bring
Pi Day is March 14th.
But we all bring
But you'll be at home, so you can celebrate it at home.
But we all bring coffee. We all bring coffee. Okay? Okay. That's it, books.
All right, where's my y-intercept? Y-intercept.
0, 0.
0, 0. And what did we determine tan was? Even or odd? All right, guys, that is it for your notes. What we're going to do is I'm going to pass out your study guide for your quiz on Monday. If you use your study guide for your quiz and on your test that's on Friday, you should be fine. Your study guide tells you exactly what your quiz is over on Monday because you need to make the study guide.